Coroutines. Oh, we love coroutines. They're amazing. Coroutines are like the little Swiss Army knife that's going to get us unstuck from many, many, many situations. They are the tool that allows us to break free of the event loop and make code that just like works really cleanly and nicely, and it's great. Um, a lot of developers, I think, avoid coroutines because the syntax is a little cumbersome and weird, and it's not always clear what they do or how and when they work. They feel a little like magic, and that's a shame. They are a little bit like magic, and that is a shame. They're not super clear. So let's back up and go over the event loop. This graph that if I have been teaching you Unity, then you have seen before, and understand how the Unity editor is running through all the code. When we have any script, any function, any block of code, C# is going to run through it as fast as it can from start to finish, period. So at some point, we need to stop that code from happening so that we can go somewhere else and like display the graphics on the screen and have the Unity's physics do its stuff. If I put in this update loop for some for loop that looped 8 billion whatever times, and did a something. I debugged out a while ago. Gosh, I'm gonna make some massive text file somewhere. If I ran this game, my game would run at a slower frame rate because it's gonna do that entire for loop. It's gonna do that entire for loop. Why am I doing this? I'm gonna crash Unity. Maybe not. I don't know. We'll find out. Yeah. Haven't gotten to the first frame yet. It's doing all the code. It's trying to run that debug.log that many times. This is a problem, as we can see. I should not have done that. It's not an infinite loop, but it's getting pretty close. So if I really wanted to do, that every single frame, my frame would take longer than a 60th of a second, which is bad. Because then my game's crashing. Let me force quit this. Okay, fixed it. Deleted that thing. Anyway, so the code runs top to bottom, start to finish. We don't have this ability to sort of execute code slowly. That's not a thing that Unity can do, because code doesn't go slow. Code just goes as fast as it can. And the Unity engine, the Unity editor, has lots and lots of features to allow us to choose when code happens. And the main ones are event functions. Functions that Unity is just going to call at particular points in time in its loop. And this is the loop. So we've gone through this before, but now we're going to go through it again with our eyes on coroutines, keeping that in mind. So at the initial scene loading, every single game object has an awake function, and then on enable if it's enabled, and awake only happens if it's enabled. Editor stuff we're still going to ignore, and start happens for all of our functions, and then we do the physics tick first, which does all this physics stuff. Fixed update we may be used at this point. On trigger enter, on trigger exit, on trigger stay, on collision enter, on collision exit, on collision stay. And then this yield wait for fixed update. Ooh, we ignored that one before, but now we're not going to. This is a coroutine thing. Let's just keep that in mind. All right. The mouse stuff, and then the update loop, and then, more coroutines. Yielding, waiting for time, yielding for web requests, waiting for starting other coroutines. Waiting for another coroutine to finish before continuing this coroutine. That happens right after update. Very, very useful. Animation stuff we skip down to late update, which we don't use very often, but when we need it, it's there. Scene rendering stuff all the way. One more yield, wait for end of frame. And then our decommissioning, our destructions. So these yield functions, they allow us to have code that is running it stops executing where it is, and it lets other code run instead. It yields, right? Anyone who has their driver's license, you yield for oncoming traffic. We yield for other code to run until it's my turn to go again. And then we continue. So if I yield for null, it will continue here. If I, right after update. If I yield for fixed update to be finished, it will happen right after all these collision events and the physics update happens after fixed update, which is nice. Yeah, and then end of frame. We can have our code run right at the end of the frame after everything else is done running by just waiting there. And we do that with coroutines. So coroutines allow our code to stop, and they allow other code to continue. Unities, the rest of the Unity event will keep running. It'll keep happening. We will be yielding until whatever point in the loop we want to yield for, and then our code can continue. Coroutines are not threads. They're not happening at the same time separately in the game loop. And that's an important distinction because in practice, we treat them as like a separate loop, a separate thread. We got our main game update loop over here. We got our coroutines over there, but they're not. It's all in one place. And if we have a lot of code in one, like a 4i less than a bajillion, it's still going to take forever. We would need to put some yield statements in there. So let's take a look at a very quick example. This is not a coroutine. This is just a very simple block that moves to the right. Oh, it's very good. Love that block. So how it works is I have a timer, and in update, I am increasing that timer at half a unit a second, and then I am positioning the block from somewhere in between point A and point B, depending on how much between 0 and 1 this timer is, because it's a lerp, it's a linear interpolation. We've covered that. If you haven't covered that, go look elsewhere. I'm assuming we know what lerps are. So we can stick some value here and move our block just by positioning it. And that's cool. That's good. It's fun. But it's kind of annoying to do this in update, because what if other code is happening? Or what else is happening in update? And I have a timer I'm keeping track of. It would be nice to be able to just call a function like move, but that function happened over time. And that is exactly what a coroutine is perfect for. So let's make a coroutine. A coroutine looks a lot like a function, but it doesn't have a return type of void. Instead, it has a return type of I enumerator. The I stands for interface, and enumerator is a word. Now, we might think to ourselves, if I want to learn about coroutines, I should probably look up that word. And we go to the documentation on C# and we look at it, and it supports a simple iteration over non-generic collection. Not helpful. Not helpful. It supports iteration. I guess that makes sense. It's like a list. It's kind of like a list. Well, our code is getting blocked up into little pieces that run at a point, and then it yields, and then it runs to a next yield, and it runs to the next yield, and we are looping through that list. So our coroutine is like a list of little code blocks that, as far as the other systems that are executing it are concerned. But we don't need to worry about that. We just need to remember what the word I enumerator is. Interface enumerator. And that is the return type. Now, I've already gotten an error because I need a return statement. I need to give back a return statement. How do we do that? We're going to yield. Oops, I forgot the important part. There you go. Wrote it in the wrong order. I wrote that in the weirdest order. I was trying to like highlight the different parts. The keyword yield we use first to say, hey, stop running the code. Stop running the code when? Stop running the code at this thing, this block, this whatever yield instruction data type is, and return the yield instruction. But what's nice about it is the code after will keep running later. And then we can yield with this gibberish. Man, I'm gonna take a sip of coffee here. I just stumbled over the word gibberish. Okay, so our code happens until it hits this yield statement. Yield is the keyword yield, and then returning some yield instruction. We don't know what those yield instructions are, but we can take some educated guesses. There's probably, if we just say null, there's probably one for waiting for seconds. There's probably one for waiting for fixed update. Probably waiting for another coroutine. That one's super useful. Null is the simplest, so we'll just do that one. Yield return null. Have this yield instruction. It's empty. Okay, we'll just do the default. Just wait till the next update loop. Or wait till right after the next update loop. Thanks. So debug.log, the coroutine has started, and debug.log, the coroutine has finished, and debug.log update has happened. But if I run this code now, nothing's going to happen. It's not going to do anything because this function isn't getting called. So, I wish it were that simple, but it's not. We can't simply call the function. Instead, we need to tell the system that's tracking the coroutines and the list of little code blocks to execute and the yields in it. It needs to handle this object in memory in a different way. And all of that fancy stuff that it needs to do, we need to call the start coroutine command, and the start coroutine command takes an object of type IEnumerator. But really, we just give it that function. We call that function inside of it. Start coroutine, move to the right. And now we should see, we should see the word start appear in our console. And then normally we would see the word update appear, but here we're starting the coroutine. So let's see what happens. Okay. Let's ignore all those update loops. The first thing we got was the word start. Then the coroutine started. So we went from here, and then we started the coroutine, and then this code started happening. Boop, bada, boop, bada, boo. Cool. And then we hit this statement. We didn't keep going all the way to the end of the code block. Once we got this statement, we paused, and we continued executing that first frame. And that got us to this update loop. And in this update loop, we spit out the word update, and we got to the very end. And we went all the way through, all the way down. So we got, we did start, and then that started the coroutine and called that first block of code. Then it hit that yield. Then we went all the way down to update, and all the way down to the next loop. And then the next loop happens, we hit update again, but now we are yielding, and at this point in time, after that second update loop called, in the second frame of the game, we spit out this second message. So there was that second update loop, so these two happened sort of in one frame, these two happened in one frame. Let's do a little loop here. So that's just, I don't know, some number of times. Let's just spit out this message and then wait and see how it happens as we go forever. Forever. So we begin, coroutine starts, we're about to yield, and then we yield. Yield return null. Then those two update loops, the one from that first frame, the same frame that start is in, and then after that we get to the next frame. And update happens, yield return null. 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 Update happens, right? So the fact that that update happened twice here doesn't like, it looks like a bug because of the way that these debug messages are laid out. Really what we're happening is we're doing an update, we're doing all the code in update, and then we're coming down and we're doing, we're continuing where we left off here, which is a loop, and it just puts us right back here and stops again, all the way until we get to the bottom. After 100 of these messages, probably could just search for it. Coroutine is finished. There it is. Field update. Coroutine finishes. Neat. So this function took 101, 102, 101 frames to execute, as opposed to a normal function, which would execute immediately all the way through from start to bottom. And that's awesome. We can do all sorts of fun things with that. Let's actually make this move to the right code move to the right. So here's how we're going to do it. We're gonna get rid of the timer. We don't need it. Delete you. And we'll keep our start and our end in that function. Define some variables. And then we want to lerp. So we want to lerp between start and end by some value. Float t equals 0. So I want to increase this value by some amount, and then loop for the amount of time it takes to get it from 0 to 1. And then once it's at 1, I want to end the coroutine. So we're going to use a while loop. And normally we would be very worried about while loops making infinite loops, but in this case, it's not going to crash our game. It's less than 1. In this case, it's not going to crash our game. Well, it will crash our game. I need to increment t. But once I'm done writing the code, it shouldn't be able to crash our game, and we should increase it. So let's set t equal to t plus time dot delta time over 2. Same thing as before, just make it go up a little bit slower. And then let's yield return null. So the code's going to go at the start, boom, down. We're going to increase t by some very small amount, the amount of time that has passed since the last update frame. Because we're yielding for null, it's basically the same amount of time will have passed since the last time it was here on this frame. And then we will move the position to some new position depending on what that t value is until t is greater than 1. Then we will just, t is never going to be like exactly well, that's not clamped. It's not unclamped. So yeah, it'll be like t will be like 0.9999. So our position will be like 99.999% the way to the end. And then t will go from being slightly less than 1 to be slightly more than 1, and then we'll finish. So our position will never be exactly this value. It'll be like 99.999% the way there. So we just, okay, now you're there. And normally we would set our position to start to be, like transform.position. Offset it by our current position so that when we call this function, it doesn't just like jump to somewhere else. It just stays where it is. But anyway, we define some start and end value. We don't change those. And we define some t value. We change t, and that moves our object. By, this yield return null will mean this will happen once per frame, just like an update loop. So let's see if we have successfully done nothing. We're still starting the coroutine and start. Where'd my cube go? Yeah. Yay, I moved a cube. But I moved a cube without needing like an update loop. I just have a function that moves the cube, and whenever I want to move the cube, I can call the function that moves the cube. that's it. So let me show you one more example. We're gonna do another enumerator. We're gonna call a time delay then move. And in this enumerator, we're gonna call that function. But before we do, we're gonna use another one of my favorite another one of my favorite functions. Wait for seconds. Yield return a new whatever object, yield instruction that wait for seconds gives us, but it will effectively, we can just memorize this syntax and it will be like, okay, go here. And then after 5 seconds from this point of time has passed, we will continue. And what we'll do is we'll do another start coroutine. We can yield for them, which is nice. But that's like a more fancy coroutine stuff. So we'll do time delay then move. So I should hit play. Start will happen. This coroutine will happen. It will wait 5 seconds. After 5 seconds, it will move to the right. It will begin moving to the right, and so on. So I should hit play. Nothing should happen for 5 seconds. And then it moves to the right. That's difficult code to debug. You're just sitting there waiting, trying to figure out how long has it been. If it doesn't work, oh no. So that's really nice. One other, I want to, right, we've seen invoke repeating or invoke. We could replace those with coroutines that we have more control over. We can cancel. We can break out of it. Yield break will just end a coroutine right then and there. We're done. Which is nice because you don't want infinite loops, or you want to be able to like stop moving. If stop moving is true, yield break, something like that. But anyway, let's put this into a real project. And we're going to do that in the next video. I'm going to split this video up.